knowing that Americans, particularly in Californians, are very interested in earthquakes. They worry about
Oh yes,
the big one.
the big one, San Andreas Fault.
Yeah. Of course, there's New Zealand, Japan, and a lot of other places are on this Ring of Fire. South America, Ring of Fire around the Pacific,
Yes.
which is where the plates that are coming out in the Pacific are colliding with the other stuff, and
Yes.
a lot of action happens there. So these areas all can have very big earthquakes at times, compared to in the middle of plates where nothing much happens on the earthquakes.
Yes.
So I got some data. There's 806 earthquakes in the sample from California between August the 31st and October the 5th, 1995. So it was around this time that I did the study. And what I was looking for is I knew that when you have an earthquake, if that's the Earth, something happens here, a shock wave goes out across the Earth,
Yes.
and in fact it's measured in many seismic laboratories, and they can
Yeah.
work out where it came from and how strong it was and all of that.
Yeah.
But that wave, I found out how fast does that go, and I thought, okay, it could go right to the far side of the Earth, and then passing through there, come back again to the same point,
Right.
and maybe there'd be a slight tendency to have an aftershock at that particular time when the energy's focusing back on there. This idea came about from my wobbling cups of tea and things, and seeing these waves do that. So, so I did, okay, let's look for that.
Now look for that because you knew their speed, so you could estimate their
yeah.
time.
So the expected time, the time I was expecting, one of those stronger waves was expected at about 54 minutes.
Yes.
But there's a number of different waves over a range, so I wasn't fixed in that period, but something around there I was expecting to be the time for a wave to return. So when I did the study, what I did is for each of these 806 earthquakes, I looked at the following 240 minutes, and I plotted how many events happened in each minute.
Yes.
In fact, I did it out further than that, but this is showing that part. So I was expecting maybe there'd be a peak about that often, but in actual fact there's another peak here, right? There's a peak here at 25 minutes, at 52, at 78, 104, 110, 130, 132, 159, 185, 213. Now those arrows I put there are regular 26-minute intervals, and we can see that something's tending to happen at regular, about 26-minute intervals.
And they are hovering around those points.
Yeah,
Yes.
quite close to this. Sometimes 1 minute off, I don't know why. But anyway, that's that case, it's got a minute off on either side.
Yes.
But quite clearly something's happening with 26-minute interval. Now, I thought, that's strange. It'd have to be having a premonition, to do that, because it hasn't got there yet. It can't get back to there. It's only just got to the far side of the world in that time.
Yeah.
So unless the far side of the world had one then, which it probably didn't, it wouldn't happen there. So a little bit of a mystery. And then I began to think about it. There are oscillation modes of the Earth, and the Earth is always constantly ringing a little bit from them.
Yeah.
What we've got to imagine, I can't do this so easy with my hands, but imagine a grapefruit, which is squashed a little bit that way,
Yeah.
and a lemon, which is extended a bit that way,
Yeah.
and an orange, which is spherical. We're basically going grapefruit, orange, lemon, orange, grapefruit, orange, lemon, orange. So the thing is doing this sort of a thing.
Okay.
If the Earth were to do that,
Yes.
it would that would have a period of 26 minutes, because that side that's squashed in on the other side, that wave comes to here in 26 minutes, and it's back in again, right? And in between it goes through that. So,
So the echo of the initial vibration hasn't bounced back yet.
No.
But the minute changes caused in the Earth as it shifts to these different ovates.
no, because I'm saying forget about the earthquakes.
Yeah.
Think about the Earth doing this,
Yes.
right? It's going to oscillate with that period. Let's supposing that the guys that study general relativity are searching for gravitational waves, right? Let's supposing there are gravitational waves, and there's some that have a period somewhere near 26 minutes. Then, even if the Earth, even if that's not quite right, if the Earth might have a 54-minute or a 20, it might be slightly off that. It doesn't matter. If there's a wave coming through the solar system of general relativity gravitational wave,
Yes.
the Earth would be doing this sort of a thing, right?
Yes.
Now, if it's doing that sort of a thing in response to that wave, then the initial earthquake happens when the wave is at the particular point in the cycle, right, of maximum distortion. and the subsequent ones aren't actually being caused by the initial one, they're being caused by this continuing oscillation, right?
Yes.
So what we get is this pattern of things. Now, I may be wrong about that, but it's an explanation for why this would happen.
Something to look for.
And I can't think of any other explanation other than something coming from outside the Earth that would cause these to happen at half the interval you would expect.
Yes.
Expect just if it was only internal Earth dynamics. So it's an area to study more.
Yeah.
They've making these instruments that they put in space. I think there's some up there, but I'm not sure the particular period or frequency that they're looking for gravitational waves. I don't think it's in this range. I think they're in the wrong range. I think that the 3 and 6 minute wave and the 80 and 160 minute waves will also show up as gravitational waves, and that they should be looking at those ranges, and I think they will find things. I've tried to suggest this in various physics forums and things that mostly people say they don't understand. But eventually someone will discover some and they'll be in that range, and then I'll be able to say, look, I told you that 20 something years ago.
Well, hopefully this video will help bring further investigation into those periods.
Yeah. So that's the a very clear pattern there of regularity in earthquake aftershocks or earthquakes themselves. When we analyse that for the frequencies present, we find that there's actually multiple: 2.97 minutes, 6.06 minutes, 12 minutes, 25.6, 27.7, and 128 minutes. Now these two are centred on 26 point something minutes, so that's what we're seeing out there.
Yeah.
But we're also seeing not half of that, but less than half, but 12, 6 and 3 minutes.
Yeah.
These 3 and 6 minute ones, and sometimes 12 and other ones, these waves that I say related to the inner planets and the sun. And they're showing up here quite clearly as strong things present in the earthquake thing. So
They are.
so these are waves that we know are linked to the inner planets and to the sun. So they are coming from outside the Earth. So it seems logical, if these are coming from outside the Earth, that this is also.
Yes.
So yeah. So
And if you had more data over time, maybe that 2.97 might come closer to 3. Maybe that 6.06
well,
would come closer to
these
6.
periods should be fairly close, because we've got. Let's see how much time we've got here. We've got September, August, September, October. It's a little over a month.
Yeah.
So in a month, we've got about 35 days there. A 6 minute wave will do 10 oscillations in an hour, 240 in a day. In a month, it'll do about 7,000.
Yes.
So this will be accurate. 6.06 will be correct.
Very good.
Okay, so these figures are correct. Why that's not exactly half that, I don't know. But those are the periods it's found.
Yep.
It may be that if you had a longer period, you'd get slightly different values, but there shouldn't be a lot. Or it may be, see, you can often get a little bit of detail around it. It may be modulated by something else. So it may be different over a longer period. But those, we can say that there are periods close to 3 and 6 minutes that are present.
Yes.
In those earthquake
Yes,
patterns.
indeed.
I think this one is actually showing the timing of those earthquakes over the period, so we can see when they actually occurred. I'm zooming along there, and you can see each of those vertical lines is actually an earthquake time.
Yes.